Hello and welcome students to the course of MS 495, that is Green Supply Chain Management, and is being offered by the Department of Management Sciences at GIKI Institute. The course is being offered as a part of Spring 2020 semester. Getting ahead or starting with our lecture, let me tell you that this is the first lecture series for an online education system. As we all are well aware that in the current circumstances, all the universities around the globe have switched towards online education. Therefore, it is important to really understand what this online education system is about and how are you going to be assessed. So, I have highlighted the online education system in three main steps. The first one is listen the recorded lecture, which is already being done, and the link will be shared with you. The next part is join the interactive session with your teacher and ask your queries that will make sure that you are learning and try to get most out of the online education. And finally, you need to complete an assignment that will be given at end of each and every topic. So these are the three simple steps which may really help you to get the most out of online education system. So, students, moving ahead, I'd like to discuss the pre-made course content that has already been covered in the topic in the subject of Green Supply Chain Management. So getting on with the topic list, the first one is Introduction to Green Supply Chain Management. Then we had Sustainability and Emissions, where we had discussed the 12 Sustainable Development Goals as advised by the UN Council. Similarly, we also studied various sort of emissions, that was Scope 1, Scope 2 and Scope 3 emissions. The lecture was followed by a topic of global and local relations. Basically, that was more focused towards stakeholder engagement. Then we had closed loop supply chains, where we had been discussing or focusing about recycling and many other measures. Similarly, we also had renewable materials management that was linked with sustainable purchasing. That was obviously followed by green inventory management, and finally we had studied green logistics before your midterm, and all this content is something that has already been covered in your pre-mid content. So today we'll be going into the post-mid topic, and I'll try to make sure that you understand, because this is your first formal session for an online education. Therefore, it is important for me to make sure that each and every of my student is adapting quickly to the system, because in case you don't adapt to the system quickly, this is something that won't help you a lot. So I expect you to give your maximum input, give us the feedback, and hopefully the things will turn better over the period of time. So moving ahead, people, today's lecture is basically about life cycle assessment, or commonly known as LCA as well. So basically, before I start my lecture formally, I'll try to let you know that how I have divided various sections of this topic, life cycle assessment. So for week 1, which is now, or your week 9 after your midterm, we will have one lecture, session 1, that will be a recorded session. The session will be uploaded on YouTube and the links will be shared on CMS portal. Plus, also your slides will be shared on the CMS portal. Similarly, for week 1, we'll have one more session, that will be your session 2. The same pattern, recorded and uploaded on YouTube. Finally, the links will be shared on CMS. And at end of the week 1, you will be given some time after the recorded sessions so that you can prepare before coming into the live session. So for the live session, you'll have an interactive session with me. Try to ask your queries, and I'll try to put up random questions to all of you. That is more towards like in-class participation. So the better and the effective you participate, the more you learn out of these slides, the more you learn out of these lectures. That is something that is more valuable and will be beneficial for you as well. So week 1 is basically about covering the basic aspects of life cycle assessment. Similarly, moving ahead with our week 2, where we will continue the same topic, that is life cycle assessment. We will have the same pattern. The first 2 sessions will be recorded sessions. The links will be shared on CMS portal. Similarly, at end of week 2, you will go through an interactive session with me. Try to make sure that you ask the maximum amount of queries, because this section will also have numerical part as well. And also I'll try to make sure that I give you the relevant examples while teaching this. So this is something that can take longer than an hour, but hopefully that should not be an issue because we are here to learn. So similarly, at week 2, once I end this session, I'll give you a short brief about the assignment that is expected from this topic. I'll let you know about the key objectives and the key deliverables of the assignment, how people need to organize themselves, how the assignment will be submitted. So finally, and the detailed document about the assignment that is more concerned about the rubrics that will be uploaded on CMS. And finally, at end of week 3, you need to submit me your assignment, and I will give you the leverage for a Sunday as well. That will make 9 days once you have completed the lectures. So you have 9 days to complete your assignment. The word limit and each and everything will be communicated as we go through this course. All right, people, starting on for the topic life cycle assessment, let's really have an idea that what the students are expected at the conclusion of this topic, what the students should be able to know. The first part is that the student will be able to understand what an LCA is. The students will learn the application areas for LCA. Similarly, the students will learn the standards and the common frameworks being used to measure LCA. Also, the students should be able to perform LCA relevant calculations. And finally, once the topic concludes, the student will be able to identify hotspots in supply chains using life cycle assessment. So these are the key learning outcomes that are expected from you. So starting the lecture, the first things first, LCA has many names across the globe. The first one is life cycle assessment, as we are calling that. A few countries call that or know it by life cycle analysis. Similarly, a few countries call it an eco-balance, and a few countries call it as Cradletograve. So the first part is really, let's talk about the definition of an LCA. LCA is basically an environmental accounting and management approach that considers all aspects of resource use and environmental releases associated with an industrial system from cradle to grave. So once we come to the word environmental accounting management approach, multiple avenues of learning and multiple new concepts arise in your mind. So in case, I'll try to go for this with an example. Supposedly, obviously, for any process, for any sort of industrial process, there are various things that degrade the environment, that can potentially degrade the human health as well. And as you are quite well aware that these are some things that are relevant to your sustainability criteria that have been revised by UN, and that has now been a part of your 12 SDGs. So basically, we are looking into the various damages that can be through any product, through any sort of a process, or by any sort of a site. That the site can be any sort of a power generation, coal power generation plant, which is like putting up emissions to the environment, and you are taking into account all those emissions and how they are degrading your environment. Similarly, you might also take the other emissions that are degrading the human health. So this is basically a vague idea about really what an LCA is and how do we start with it. Diving deep into that, specifically, it says that LCA is a holistic view of environmental interactions that covers a range of activities from extraction of raw material from earth and production and distribution of energy through the use and reuse and final disposal of the product. So basically, if I really need to tell you that what this is all talking about, I'll go with the example of this milk bottle. This is a bottle made through plastic that has polypropylene, polyethylene. There might be high density polyethylene as well. And we are all well aware that plastics have a negative impact on the environment as well. And processing plastics also has a negative impact on the human health as well. So in case we need to perform an LCA study for this bottle, the first part is that we say that, all right, we've taken into account that how much energy consumption or how much CO2 emissions or carbon monoxide emissions were emitted while processing or extracting raw materials for this bottle. Similarly, the process was followed by obviously some sort of a manufacturing process where all the elements were mixed, compounded together, and finally molded into some sort of a plastic shape. So basically, getting on to that point as well, we come to know that obviously each and every manufacturing process has various sort of emissions associated with that can be direct or your indirect emissions. So we take in account all those emissions as well. We also come to know that how they are degrading the environment or the human health or the climatic conditions around the globe. Finally, bottle is used and finally disposed of. There are multiple ways for disposal. That can be your landfill, that can be through composting, that can be through recycling. So it all depends that what sort of disposal methods you go through and what sort of energy contributions or emissions or negative environmental contributions do you put up. So accumulating all these processes that initiated from basically sourcing polypropylene, processing polypropylene and polyethylene, finally blow molding, injection molding into this shape, usage, and finally disposing thereof either through recycling or landfilling, we come to know that across the entire life cycle of this milk bottle, there are various stages and various processes that have negatively impacted your environment and or potentially have negatively impacted the human health as well. So basically, once we accumulate all these effects and take in account of effect of all these parameters, this is basically what an LCA is. And the key important part for LCA is that an LCA is a relative tool. Basically, LCA is always used for the purpose of comparison. LCA is a comparative study. I gave you an example for this milk bottle. Supposedly, this might be using 70% polypropylene, 30% polyethylene, and I might be comparing this water bottle to some other manufacturer that might be using 50% polypropylene and 50% polyethylene. So I can't have an LCA for any single object that is like an absolute object. I can't have the LCA study. I need to have a comparison as well. Basically, this will really tell me that which one is more environmental friendly or human health friendly, the 50% one or the one that is using polypropylene as 70%. So far, I hope that through the definition of LCA, you have come across to know exactly what the study of LCA is about. Alright people, in my previous slides, I told you that LCA is also known as cradle to grave. You may call this as a new theory as well. So starting on with this schematic, what we come to know that the first part, resource acquisition, then we have material processing, production, usage and maintenance, finally disposal, can you reuse or might go for recycling, where we might reprocess any sort of material by melting it or by any other sort of process. So basically, the cradle to grave thing I'll try to explain through the schematic is that the cradle is once your material is formed or once the initial resources for the material are required, that is your resource acquisition stage, and grave is once your material is or the product is disposed of. So basically this entire study is taking into account from cradle to grave and also taking in account of the reuse and the recycling as well. So basically this is the key idea behind the cradle to grave when the product initiated, and finally how the product was disposed of, and taking into account all the environmental, the human degradations that have been a part of the process. Getting ahead, I'll try to just give you an idea of the basic processes of a life cycle for any sort of an industrial product. The first one is your extraction phase. Obviously you need some sort of raw materials and you need to extract them from the ground, followed by obviously recycling and disposable as a waste. You might use some other elements as well. You might recycle them, you might add them for raw materials, then you have packaging, then you have marketing. Finally, the product is used and might be recycled again or disposed of again. So this entire circle keeps on working. So this is basically telling you about the key points that might come up within a life cycle of any sort of industrial product. Okay students, getting on with the definitions, as I told you that cradle to grave is something when the product initiated and grave is something when it is disposed of. So these all the inputs and outputs are considered for the phase. For example, as I already told you about this milk bottle, that the cradle is once I acquired the raw materials and the grave is once this product is disposed of. So this is giving me an idea about what the cradle to grave sort of emissions might be throughout the process or in the cradle to grave life stage. Similarly, I do have another terminology that is known as cradle to gate. Cradle-to-gate is an assessment of a partial product life cycle from manufacturer to the factory gate before it is transported to the consumer. The use phase and the disposable phase of the product are usually omitted. So basically, getting an example for this, I do have a brick lane. I say that I source the materials. The material is manufactured in the brick lane. The brick lane is emitting some sort of emissions. And finally, I put all the bricks for sale. So basically, I start on with the time the product was initiated. That was cradle. I source the material, the transportation, the distribution. I take in account of all the emissions relevant to that. Then I process that. Obviously, I'm using some sort of renewable or non-renewable source of energy. That is also contributing to some sort of emissions or energy usage as well. And finally, I keep that thing up for the sale. So basically, I am more concerned about this is more of a cradle to grade phenomena, that I am basically concerned about my manufacturing processes rather than taking responsibility for the disposal of product as well. Similarly, the new concept that is cradle to cradle is basically a specific kind of cradle to grave assessment where end of life cycle step for the product is a recycling process. From the recycling process originates the new product. Simple. Supposedly, I say that I go and dispose of this milk bottle. What they do is try to extract the polypropylene and polyethylene out of that, and obviously that makes a new material or a new raw material. So basically, the energy consumption or the emissions that have been used for making that polypropylene or polyethylene into its genuine shape or genuine form is something that is further accumulated into my life cycle assessment calculations, apart from the ones that were in cradle to grave. So cradle to grave plus recycling, that is cradle to cradle. Okay students, quick thing that there are two types of life cycle assessment studies. The first one is for product systems that I've already told you. That might be a milk bottle, that can be any sort of product. Similarly, we do have site-oriented life cycle assessment as well. What is happening in this site-oriented life cycle assessment is basically there might be an oil rig. The oil rig is obviously using electricity. They do have their own generators as well. They do have their own processes as well. They do have their own transportation, distribution resources and logistics resources as well. So what is happening? All these things are contributing to some sort of environmental emissions. They are using some sort of renewable, non-renewable energy sources. So all these things are contributing negatively towards your environment. So this is how I can accumulate all my points for my site-related emissions. All right, students. The next part is obviously, hopefully, that you would have a better idea and an understanding that exactly what an LCA is so far. The next part to understand is that what are the key application areas for life cycle assessment. I have made a video for you. Hopefully, you will have a good idea through this video that exactly how the companies like Nivea and Gore-Tex are basically using life cycle assessment study to make better performing products. So I do hope that listening to the video will further enhance your concepts.
I got two drawers here with me today. One is made out of glass and one is made out of plastic. When we were designing our new Nivea face care range, we asked ourselves which one is the more environmentally friendly material. So answering that question is not that easy. There are a lot of things to consider, and that's why at Beiersdorf we have chosen life cycle assessments, also called LCA, to look into the environmental impact of our products through every single stage of the product life cycle. We are starting at raw material extraction, production, transport, consumer use, disposal and recycling. We're looking at things like how much energy is being used during production of the jars. How are the jars transported? How far do they travel and by which mode of transport? And what happens to the packaging at the end of product life? When looking into environmental impact, we are looking into different impact categories. That is greenhouse gases, which go together with climate change potential. We also looked into how much waste is being generated, how much wastewater, and what is their impact on the groundwater and soil. what we found was not exactly what we expected. The plastic jar is more environmentally friendly than the glass jar. We were able to reduce the greenhouse gas emissions by 15%, which is a huge saving. And that happened without actually damaging or harming the other environmental impact categories like soil and water. The main reason for this huge saving in greenhouse gas emissions lies actually in the production of the raw material itself, which is that there's far less energy being used to produce plastic that we use rather than the glass. And we could achieve an even greater reduction of greenhouse gas emissions if the consumer chooses to actually recycle the packaging rather than just putting it to the dustbin. So from here on, we're going to use life cycle assessments to identify the hot spots in our products, and that through our entire product range. And that we will use to work with our research and development to develop more environmentally friendly products, and also to work with our packaging suppliers and raw material suppliers to identify what we can do better. This will help us to achieve our sustainability target of making 50% of our sales with products with reduced environmental impact by 2020. So that's a huge achievement we've made from just 3 little letters, and it's just one more way to show we care.
Alright students, through this video, I'll try to highlight the key important areas in case you are not able to hear the audio. What exactly happened through this video, or what exactly have they told us about? The first thing is that basically it is a comparative study. They try to measure the effect of plastic glass against glass packaging. Similarly, they also try to take in consideration all the areas that are through from the resource acquisition stage to the final disposal stage, and they came across a conclusion that may help them to overall increase their sales by 50%. So this is how the companies are trying to make more use through using life cycle assessment studies. Getting on to our next application area for life cycle assessment, I want you to go through this video, listen what they are saying, and how this company Gore-Tex is basically using life cycle assessment study to achieve some sort of sustainability, because that is the entire aim. You conduct the life cycle assessment study, you find the hotspots, and finally you try to eliminate them, and finally you are more target oriented towards your sustainability goals.
What is a life cycle assessment? Life cycle assessment, or LCA, is an internationally recognized standard and currently the best method available to scientifically measure the environmental impact of a product. The great thing is, LCA doesn't consider just one aspect. It looks at the bigger picture. By analyzing the whole life cycle of a product, from raw material extraction to disposal, and by looking at different factors like energy consumption, carbon emissions, and water pollution, for example, in each stage. The final LCA report summarizes the various impacts of the product and translates them into 20 different indicators. That holistic view from cradle to grave enables us to identify how to minimize the product's impact. But what does that mean exactly? Let's take the indicator global warming potential, also referred to as carbon emissions, as an example. In 2013, we measured the environmental impact of a typical Gore-Tex outdoor jacket. The results show that production and distribution have the greatest impact. 65% of the global warming potential measured in CO2 equivalent occurs at the beginning of the jacket's life cycle, whereas disposal contributes less than 1%. This means that the less often a new jacket needs to be produced, the smaller the impact on the environment. In the LCA, we assumed that a Gore-Tex jacket was worn for 5 years. That comes with a carbon footprint of 72.7 kilograms CO2 equivalent, which is comparable to the environmental impact of driving a mid-sized car that consumes 7.5 liters fuel per 100 kilometers for 270 kilometers. What if you need to buy 2 less durable jackets in this period because they fail early? This would result in carbon emissions of 120.12 kilograms CO2 equivalent to stay dry and comfortable during the same period of 5 years. Transferred to our car, you'd caused an environmental impact of 442 kilometers instead of 270. If 1 million consumers choose to buy a more durable jacket half as often, this could save the equivalent of circling the globe 4.5 times with that same car.
All right. I do guess and I do hope that these videos would have surely cleared your concept that exactly what is the use or what is the benefit of using an LCA study and how the companies across the globe are using life cycle assessment study. Exactly, I won't get into detailing the points because each and everything has been highlighted and the slides have already been uploaded on CMS portal. Alright people, how exactly LCA can help us? First thing first, identifying the opportunities to basically improve the environmental performance of products at various points in the life cycle. Similarly, LCA can help us in informing the decision makers in the industry, government, or the non-governmental organizations for the purpose of strategic planning, priority setting, product or process design or redesigning. Similarly, LCA can also help us to selection of the relevant indicators of environmental performance, including your measurement techniques. Similarly, LCA can also help the marketing people, example, implementing an eco-labeling scheme, making an environmental claim, or producing an environmental product declaration. So almost these are some of the things that have already been highlighted in the video that you might gain some sort of marketing advantages. You might go for some sort of a policy making. You might use LCA to identify the hotspots and bring in improvements in those. So these are some of the things that exactly LCA can help us. Getting into some details exactly how LCA can help the analysts, because this is something that might be relevant to you, because exactly you might end up having a job of an environmental analyst. So this is something that how LCA study might be able to help you or the company that you're working for. The first part is develop a systematic evaluation of the environmental consequences associated with a given product. Analyze the environmental trade-offs associated with one or more specific product process to help gain stakeholder acceptance for planned action. Similarly, LCA can help quantify environmental releases to air, water, and land in relation to each life cycle stage and or major contributing process. Sorry about that. LCA can also help assist in identifying significant shifts in environmental impact between life cycle stages and the environmental media. Similarly, LCA can help assess the human and the ecological effects of material consumption and environmental releases to the local community, region, and the world. LCA can also help you to compare the health and ecological impact between two or more rival product processes, or identify the impacts of a specific product or the process. And lastly, LCA can help identify impacts to one or more specific environmental areas of concern. So these are basically more of an advantages or exactly how LCA can be used by the analysts for some sort of practical usage. So people, I'll be going through example of common LCA studies that are being practiced globally for various sort of industries and various sectors, and I won't be getting into the details as exactly how these are helping, but just a quick review. LCA of energy systems. Energy systems might be your comparing between renewable and non-renewable energy systems. Similarly, electromobility, you might be comparing your hydrogen fuel cell power vehicle through with hybrid power vehicles. I'll be just telling you a bit about the application areas because this is something that might help you once you are selecting the right topic for the right product for your assignment that is due at end of this topic. So electromobility can be comparison of a hybrid vehicle to a hydrogen fuel cell powered vehicle. Similarly, for building and the built environment, you might compare the traditional construction with the agile construction, or you might compare various sort of means of disposal of the construction material. Similarly, you might go for food and agriculture. You might be comparing how various genetically modified foods or genetically modified seeds might be better environmental performing than the ones that are not traditional ones. Similarly, biofuels and biomaterials, that is more towards biodiesels. Similarly, you might have a study for chemicals as well, nanomaterials as well, or drinking water supply. Similarly, wastewater treatments, that obviously you might have a process A, then you have a process B. So which one is contributing less towards the environment and which one is the most better to be used of? Similarly, for solid waste management, you have a lot many ways that might include landfilling, that can be composting, that can be recycling. There are a lot many ways, and you might be comparing for any single sort of a process for any particular product, that exactly how LCA, how sustainability wise and environmental friendly wise, or how human health wise, this is a good process as compared to the other ones. Similarly, you have LCA of remediation of soil and groundwater. All right, people, coming on to the last slide of the topic, that is more towards like a summary of the session. I'll try to give you a quick summary that the initial learning outcome that we had was what is an LCA. We learned that LCA is an environmental accounting system. Similarly, LCA takes into consideration the human and the environmental health hazards and are used as indicators. Similarly, we came across the terms Cradletograve, cradle to cradle, and various other terminologies. Similarly, we had a learning outcome of 2 that was more relevant to the application areas of LCA. And what we learned was basically using LCA studies might help to leverage your economic benefits. LCA, similarly, we also studied how exactly LCA helps the business analysts. And lastly, we had also an idea of exactly what are the common areas where life cycle assessment study is being practiced. So with this, students, we end our session 1. Hopefully you will go through the slides. Hopefully you will try to put up your questions. Hopefully you will write your questions. And once you come up in the interactive session, I hope that each one of you will be putting up their maximum efforts, trying to put up maximum questions for the instructor. So basically you can have a better understanding of the topic. This is a quite important topic that is a part of every course or the instructor that is teaching green supply chain management. So make sure that you go through each and every bit of this, because this is quite important. And I think, and I do hope that I'll see you in the next upcoming session. Thanks a lot for listening. Happy holidays.